Great. Hey, my name is Steve Vandenberg. I am the team lead for security for BC Hydro's Smart Meter Infrastructure Program. This is Bob Hawk, my teammate. We've got a full scope 1.8 million meter deployment in British Columbia, Canada. So many of you are probably better pen testers than I am. You can make perhaps Nessus sing and dance. Some of you may be able to go barehanded on the code and find 0 days, and I very much admire those skills. Myself, I've put together security programs for large organizations, including security testing, and I've got some learnings and observations that I'd like to share with you and hope that you'll be finding useful. So here goes. So first, the disclaimer. This presentation is not about anybody that myself or Bob has worked for. First, a big shout out to my homies at BSides Vancouver. We've got a great InfoSec community up there and a beautiful city. So if you have the opportunity, please come up and check it out. It's happening March 15, 2015. So first, some example AMI hacks. AMI, Advanced Metering Infrastructure, has gotten to be a very crowded space for security research. These are by no means the only recent hacks out there. They are, four that I have some interest in, so I've wanted to share with you, just from the point of view of showing you that it's a crowded space. It's a space that's getting a lot of interest, both from the good guys, the InfoSec community doing some good research, and the bad guys. So this is what we need to think about when we're looking at developing testing programs. Looking into the eye of the meter, Don Weber did this at DEF CON in 2012. This is a hack that's got to do with interfacing with the optical port. The optical port on a meter is a maintenance port. And if you talk to it right, you can get the meter to do a bunch of unexpected stuff. Puerto Rico utility found this out, or one like it, when they experienced an optical port hack, which was an inside job to lower electric rates for people that could pay the corrupt insiders. This was investigated and, case closed by the FBI. It was reported by Krebs on security. Those two have to do with the optical maintenance port as well. We've got an RF hack that was given at the Chaos Communications Congress in 2011. What they did was they looked at the privacy implications of the RF emanations from the meter. The meters got RF emanations in a couple of ways, both the radio frequency and mesh that goes back to the utility, also the home area network. Looking at the radio frequency emanations, they were able to look at not only when people were home, but what kind of appliances were running, perhaps even what people were watching on television. A lot of the angst out there over AMI deployments is going to be over privacy issues. People have got a lot of concerns over, what can I do with the data in a smart meter if a smart meter is co-opted versus, a flywheel meter, which was, an old style flywheel meter, which really had nothing that could be used by a bad guy. This was a really nice presentation. We Are So Screwed. Yeah, I think that really was the title, actually. Because I was unable to discern any other. This was given by Larry Pesci at DEF CON 21. And this was a combined physical and cyber assault on a connected grid router. The connected grid router is a device, it's a field area router, sits on a pole, and when those meters are all talking to each other, forming their mesh, the last guy, the 2001st meter, takes that signal, the combination of all of those signals, and hands it off to the connected grid router, which goes ahead and sends it back, you know, to the head end at the utility. And that, along with every other part of the system, is open potentially to exploitation. My system isn't open to any of these exploitations. You know, if it was, I wouldn't be standing here. I'd be on a plane back to Vancouver to either get fired or, you know, fix all my stuff. Because we do a really good job of fixing, but again, we've got to let, you know, the past be our guide. There's research going on now, and, you know, both bad research and good research that we need to protect our system from. So with that, let me hand it off to Bob, and I'll be back.
Thank you, Steve. All right, I want to talk about AMI projects and programs, and then I want to contrast AMI projects and programs with standard IT. I think a lot of people here will understand and appreciate standard IT projects over AMI. Now, AMI projects tend to be very large. They're state or province size. They're also very expensive and complex networks. Very resource intensive as well. Lots of people working on this for the deployment and the integration to the utility. There's complex and emerging technologies, sometimes absolutely brand new tech. For example, IPv6, been around for quite a long time. However, it's starting to be used en masse in AMI networks. As well, there's some older technologies that are being used in new and interesting ways. Some SCADA technologies that didn't exist in the IT world are starting to be imported into the IT world or over IT networks. AMI projects tend to be multi-year deployments. They're not spanning just a few months or a few weeks. They tend to go on for years and years and years. The very first smart grid project that came out in Italy, or the AMI project that came out in Italy, was 5 years long, and I believe it cost €1 billion. Multiple vendors are required to make AMI projects a reality for a utility. By the time utility gets into an AMI space, they're no longer just a utility. They're a conglomeration of telcos and service providers for a lot of different applications and communication networks. Now let's take a look at that contrast. IT projects tend to be 3 to 5 years for the software, hardware sometimes on a 3-year schedule. You know, you swap out servers. Windows 2003 to 2008, that's 5-year life cycle. Tend to be 1 to 3 quarters to implement. For an application into a larger infrastructure, you can have tens of servers, hundreds of network devices, and you could be rolling out to thousands of end-user devices, such as smartphones, tablets, and laptops. Now let's take a look at the AMI space. In the AMI space, we have equipment that is going to last 50-plus years out there. Some of the traditional flywheel meters that are on the side of businesses and houses have been there for 50 to 70 years. Now replacing them with smart CPU-enabled devices, and these devices still have to be out there for quite a long time. 2 to 5 year deployment for most of the projects that I've looked at. Hundreds of servers in the back-end data centers to collect this information. Thousands of network devices out in the field and even in the data center. And millions of end nodes. Sometimes you talk to IT professionals and they're like, okay, the largest network that I've worked on has had 100,000 workstations. Well, imagine a network that has into the millions of end nodes that need to be administrated and managed. So let's talk about the security test scope. The security test scope of what needs to be tested for an AMI space deployment. We'll start off with the meter. The meter can be installed on the side of a house or a business, and it can have multiple ways of communicating. Back to the utility, it can either be wireless or it can be through a PLC, a power line connection. The meter will also have multiple radio interfaces if it's a radio-enabled meter. One of the radio interfaces is a Zigbee network. The Zigbee network will allow the meter technician to associate with the meter from a distance, not too far of a distance, but from, for example, the roadside to the meter that's on the side of the house or the business. The Zigbee network is also utilized for the home area network, or sometimes referred to as the business area network, or the BAN, when it's being utilized for businesses. This is the network that is actually used for the smart appliances. Air conditioning units that have CPUs, refrigerators that have CPUs that can actually get onto this network and are enabled for things like time of use and rate of service. The meter itself will operate with the rest of the meters in its cell in a hierarchical network that is set up in a radio mesh. So all these meters will talk to each other. They don't necessarily understand each other's communication, but they will forward messages forward, and through the layers until they finally get to their field area router. So this is much like how a cellular network works for a telephone system. In the case a meter cannot talk to other meters and or to the field area router, there are RF LAN extenders that allow the signal to be captured and transmitted forward. The field area routers, as Steve was indicating a few minutes ago, are the final aggregation point before the signals are aggregated and sent off to the data center at the utility where the bills are generated and the data is analyzed. In the case of smart metering equipment, we're talking millions of meters generating the equipment and the software generating millions of lines of information. This is essentially big data, okay? This is all going back to the data center, and there's a lot of information. While we're testing all the hardware and all the software, there's something that needs to be kept an eye on, and that is the software releases. Versions and patches that are coming out over time can essentially make a testing plan obsolete or a test obsolete before the actual deployment is even over. So test plans. Test plans should have a common set of criteria and goals. The principles of these common criteria and goals have to be able to bring the utility, the vendors, and the service providers together to agree upon the language and a variety of other things so that those goals can be established. The best way to do this, we found the best way to do this was a standards-based approach. AMISEC and NIST IR 7628, the NIST Interagency Report 7628 for cybersecurity of smart grid and smart metering networks was a great way to go. These standards were developed utilizing a risk assessment methodology. The risk assessment methodology was based on controls for devices as well as the interfaces in between the devices. Something that's really important to keep your eyes on if you're looking at this space is that by the time you put this equipment together, it becomes ecological. It actually is almost like a living being. There's so many pieces to it that you can't say, okay, I've tested all the pieces and it's all good. We need to actually test the interrelations and the functions between the pieces as well. Now, what's really important is that when you're taking a look at testing the various individual components, that in itself doesn't really matter as much as how they're being utilized. And it's really important that the standards that are being adopted be use cased for the business, the utility, that is actually implementing these various technologies. Of course, there's a note at the bottom, be prepared to change the test plans based on the priorities of the test cycles and what you find out. Things will change over a long period of time. Now, this one's commonsensical. Develop a test plan beforehand. Yep, you got to decide what you're going to do before you actually do it. But a lot of people, a lot of security testers, we love to get our hands right onto the equipment and just dig right in. Create use case documents to shape your test plans. The use cases of the actors, the actual resources, and how they interrelate is really necessary. Do security assessments. This is not when you actually start looking at security tools such as Nessus or Codenomicon. A security assessment, we take a look at the use case, we take a look at storyboards, we take a look at architecture, we take a look at things like the manufacturer's documentation, the documentation that's created internally within the utility. Put all of that together to get a conceptual idea of how this thing is supposed to work, and create test plans based on that. Tie the test plan strategies back to the open standards. Why? Because you have validity and it'll be good for things like audit later on. Consider all the threat vectors. We have cyber, physical, social. In yesteryear, we used to call these physical, administrative, and technical. But, you know, sometimes times change. Let's take a look at some of these threats. Physical threats. Well, I can put a rare earth magnet right on the meter. That'll actually kind of mess with its ability to measure the power. I can take the 5-year-old approach and take a hammer to the meter. Okay? I can go into the cyber attacks, RF denial of service. The meters, in a lot of cases, will operate on known frequencies. This is forward-facing on the internet, what their frequency ranges are, and that can be jammed, possibly. The optical port attacks that Steve was talking about, there is an optical port to interface with a meter if the actual radio stage dies on it. And believe it or not, anybody can buy the optical plug-up gear. It's available online. Zigbee or DMP3 attacks. These are protocols that have been around for a while, but they're being used in new and interesting ways. And in actuality, some of them are available to big attacks, as was discovered with DMP3 last year. There is a lot of different attack vectors for that protocol. Social attacks. Somebody can call a call center and actually talk the call center representative into giving up information on a service point. A combination attack. Let's go to a big box store, buy ourselves a home area network device, and call the call center and see if we can get some social engineering in place to get that associated with a specific service point so we can find out what's going on at that service point, what types of smart appliances are there, and what their usage is. But why do we want to do this stuff? Well, the goals are at the bottom there. Possibly turn off the power, mess with the billing, increase it, lower it, depending on what we want to do. Know when people are home and what they're doing. Now for the rest of this, I'm going to turn it back to Steve. Steve?
Okay, thank you, Bob. So now we're ready to go ahead and get our test plan rolling. We've got to ensure a production-like environment. Sounds really simple, and it is really simple if you're testing a router or a meter. And what you need to do is just get the right version with the right software and move it to your lab. But that's not what we're doing here. We are going to be testing a system that's got maybe 1.8 million endpoints, the meters, thousands of field area routers, hundreds of servers. So what we need is an environment that can stand as a proxy for that, because we probably can't build that back at the lab. We're spending a lot of money on these results, so we've got to be sure that they're valid. We need not only production-like equipment, in other words, the same versions that are going into the field, but we need production-like configuration. Now, we need this for a couple of reasons. We're not testing this for a hobby, and we're not going for bug bounties here. What we're doing is we're protecting the critical infrastructure that keeps the lights on. And in order to do that, I need the results that I get to be actioned. Okay? I need the results that I get to be able to hand off to a vendor and have them fix the equipment before it goes out in the field. I need results that I can give to my implementation team to tweak configurations before it goes out into the field, perhaps. And I'm not going to be able to do that unless I can get all those parties on side. In other words, I've got to get them to believe me that this result is a valid result. And the only way that I can do that is if I've got a really good production-like environment so that I can know the issues that I find are issues that we're going to have in the field. So I already said we're not going to get 1.8 million real meters and X thousand field area routers moved into my lab. So what I've got to do is I've got to document any differences between the production and the test environment, and I've got to discuss these with the vendor and the implementation team beforehand so we all agree how the differences are going to impact results. We've got to agree that the results that I'm going to get are going to be valid, because I'm going to expect action on their parts, and I'm going to expect action with a defined process that's going to be able to, fix this stuff in time. More than that, we're going to need to build the test environment, troubleshoot it, and maintain it. Now, let's talk about that. Who's going to build a test environment? Oh, yeah, well, the lab will build it. Well, wait a minute. We're looking at a system which, while it may be built from standard parts, those parts are going to be configured in a way in my AMI deployment that's probably never been done before. Now, who's going to know how to do that? The test lab? Yeah, well, you know, maybe if they've done a lot of AMI work, but they're probably not going to be able to get the environment exactly right. Who's going to be able to get the environment to be exactly like, from a security point of view, the production environment? Well, the same people building the production environment. So I've got to have a really good liaison with my vendor and with my implementation team, my other team leads, because I'm going to be reaching out to them to build up this environment or advise my team while we're building it up, troubleshoot it, because just like we're going to have problems in the field that need, you know, good engineers, good programmers, etc., to go ahead and solve, we're going to have those same problems in the production, in the non-production, in the test environment. And we're going to have to maintain it. So we've got to know what a false positive is. I got to know the difference between a problem and a security problem. Okay, that's where the troubleshooting comes in. And like Bob was saying, I'm looking for an environment with multiple vendors' products that's got to live and remain useful for maybe 2 to 5 years. So it's going to need maintenance. It's going to need upgrade to keep it like the production environment. Big projects like AMI don't get completely designed, then completely tested, then rolled out. It's not like a cell phone. AMI, my team may be one step ahead of deployment. Now, the good news is, you know, as the security lead, I'm going to have the ability, you know, I've been given the ability by my management who understands this issue to pull the plug. Oh, that's a power joke. No, if I need to. But I don't want to do that. I mean, I've got to be in a situation where I have the ability to help deployment while maintaining the security that I need. So getting that test environment, getting the good technical advice is going to be very important to do that in a timely fashion. So before starting, okay, before I get, you know, the tools out, I've got to get the results of the security testing carried out by the manufacturer or others. This is going to help me to eliminate redundant and expensive testing and shape my test plans. For the IT pen test, think of this like a part of the recon phase. Think of it as a recon phase with lots of lawyers, okay, because there's a lot of equities at stake here. No, even if I'm a huge customer of a meter vendor or a network equipment vendor, they're not just going to FedEx me over the results of all the pen testing that they've done. Even if I've got a second eyes deal with another utility, they're not going to share this stuff freely. This is about good relationships, it's about good non-disclosure agreements, and it's about measured sharing for mutual benefit with your partners. This is going to enable me to shape the test plans, make sure that my testers are shooting with a rifle, not a shotgun, because the ammo can run into the millions of dollars. It's going to allow us to pick up where other testing left off, and it's going to allow us to further explore their findings. We're going to talk about this when we get to, you know, where do we go from here when we've got to end the program. These other utilities, other manufacturers, other service providers, they wanted to test the whole world, but they couldn't. Everybody's got limited time and limited money. So what they want to do is, and what I want to do is, I want to make sure that I pick up where they left off, and I, you know, go ahead and I run everything that I can down to ground, and then, you know, perhaps in a measured way be able to share it again with the manufacturer and with the partners so that we can all benefit. Security testing is going to need a big support structure if I'm looking at testing AMI deployments. Again, we're not looking at testing a thing. I'm not even looking at testing, you know, a collection of things, a network. I'm looking at testing, you know, a network that goes over potentially hundreds of square miles with millions of devices. And in AMI, the real benefit to the customer, okay, the user of our electricity, doesn't happen just when we get the billing information back to the meter. AMI doesn't deliver on its business case merely by not having meter readers. We do a lot of stuff with the information that we get to help operate our system better, to help people save energy, and that means that there's a big attack surface and there's a lot of stuff for us to test. So we need substantial support from the manufacturer. I should say manufacturers, because even if you're looking at the largest AMI equipment vendors, manufacturers, they don't make the whole system. There'll be the meter, there'll be all the backhaul, there'll be the routers, and then there'll be the applications that we use to do stuff with the information once we get it back to the utility. So this is a loosely coupled system, and I've got to test the whole thing, and a lot of what I'm going to be looking for is in the interfaces. So I'm going to need support for test environment, construction, and maintenance in a timely manner, because getting my test environment up and right once the stuff is out the door, not so good. Better to get it done while I can still fix my stuff before it leaves. I'm going to need defect triage, vetting of false positives. This deployment may be your first AMI deployment. The manufacturer may know more about the equipment, especially his equipment, than you do. They're going to be able to help you vet false positives. You're going to get a result. You may not know exactly what to do with it. What you need is to be able to look at that result with someone who understands exactly how things should work, maybe on how things had issues in other testing, to help you get out the false positives, get good evidence, know that they're false positives, set them to the side, and then run the real defects to ground. You're going to need their help for defect resolution. Again, I'm not looking to, put this program together to write a paper about. I'm looking to get this program together to help my province be safer. So I've got to get these issues fixed. And maybe they're going to be fixed in the manufacturer's factory. Maybe they're going to be fixed in my, implementation team's area. There's a lot of people that may need to be involved to resolve the defects, and I've got to get them on board and make them part of this. I've got to get information for white box testing. What I'm talking about here with white box testing is not setting up my red team with, admin accounts and passwords. What I'm talking about here principally is information. Now, there's always the white box versus black box debate. I come down on the side of white box for AMI deployment. Why is that? Because the same equipment is used many places in the world, and like Bob was saying, over very long life cycles. Sooner or later, a lot of this information is going to get out. I'm not talking about the proprietary information about my system. What I'm talking about here is there will be information getting out about meters and routers of various manufacturers. And when it does, bad guys are going to be able to use that against me. The least I can do, in my opinion, is give my team every advantage to find the results that are going to help me deploy safely. So what I want to do is put all the information that I can about the equipment in their hands so that they can help me out. They can use their time wisely. And all of this needs to be formed in a common understanding with the manufacturers and test lab beforehand. We're looking at potentially a long project here. People are going to be moving on and off the project. Toward the end of the project, money may be getting low, time may be getting short, and that's the time that I'd better have all this made part of the contract. So there's a common understanding as to who does what in this testing program and who's got the various responsibilities that we've talked about. So again, get this to be part of the contract up front. So, handling the results. We do a full scope test plan. We've let the genie out of the bottle if this information leaks. So it had better not. But, as always, confidentiality versus availability. I could have 300 to 500 people working on an AMI deployment. They don't all need to know the security test results, but some of them do, or at least some portion of it, if they're going to help, because I've got to get the defects resolved. I may have to tweak my schedule for deployment, and in order to do that, there's going to be, more than just my team that's got to be in on some of these results. So I've got to look at how the information is going to be handled, how I'm going to let the genie out of the bottle, but not too much, and certainly not in a way that's going to be dangerous to any of my stakeholders. Document control systems. Yeah, I'm going to use encryption, I'm going to use password management and document repositories, but don't wrap encryption around this thing, put it on a USB stick, and lock it up in a safe, because it's not going to be useful to anybody. And it's going to be less useful as time goes on. So I better make sure that the result that I got day one of my testing is available to examine a fix in year 4. So I need to make sure that I've got my stuff together with regards to a true document control system, not merely making information unavailable. Remember, if we're looking at a loosely coupled system with a utility, various vendors, various service providers, they will have a variety of infrastructures to keep this information safe. So perhaps you're living in a house, which is to say IT infrastructure, that was not designed to handle sensitive pen test results. They may never have envisioned that you'd be doing this kind of testing. So they may not have what you expect regards document control systems. Do you trust, can you trust the document control systems and the practices of service providers that you need to bring under the tent in order to fix the gear? Okay, think about that beforehand. Get this agreed beforehand. How are you going to disseminate this? And how are you going to keep it under control? Most of all, know that you are responsible for the information and what the information leakage could damage. Okay, and I mean that not only legally, because by the way, you will be responsible for it legally, but morally. You could be using AMI gear that's the same as is going to be used in France or in China by people who have never heard of your team and your project, but who will suffer if you don't do your job right. Because when your information leaks, they may not be thinking about doing bad stuff in Vancouver. They may be thinking about doing bad stuff in LA. And I don't want to give the bad guy a weapon to attack somebody who, well, I don't want to give them a weapon to attack anybody. But I want to make sure that my stuff gets deployed properly. But do think about your responsibilities here. So, using the results. Rather like a dog chasing a car, the dog better figure out what to do with the car once he catches it. So, you've got a whole bunch of results now from your security testing. Well, a lot of people say, great, fix it. Again, not as simple as an iPhone. What's going to be the criteria for halting deployment? You've got 300 to 500 people working toward a schedule that may have been mandated by the regulator. You're on a burn rate of huge amounts of money here. Halting deployment may be necessary, and my management would support me in this. But I've got to have some criteria that are going to be agreed upon. It can't be that, I hit the red button and everything stops. How are defects going to be mitigated? Okay, maybe we can wrap security around stuff. Maybe we can armor it before it goes out. Maybe I can put some armor on there that's going to be, rock solid until I can do the fix that I want. So I've got to look at, a variety of options here. I've got to look at what conditions, if any, are going to be applicable for deployment. Maybe I could change the use case. Okay, maybe this device that was to be used by my technicians to maintain the meters or deploy them, maybe it can't be used over the internet. Maybe that's just a no-go no matter how much armor I wrap around the thing. But maybe I could use it on my corporate network that's got better security. Again, I'm just saying you need to be open to a variety of solutions, not just, hey, I'm the security guy and, my answer is no. So let's think about setting an achievable goal. Okay, when we start out, we've got to think about what done looks like. Okay, I'm a security guy. I would love to test forever. I would love to keep, my team large forever because I believe that that's the way that I serve the people of, in my case, the province. But, the reality is everything's got to have a beginning, a middle, and an end, especially projects, deployment projects for AMI. Every test finding is going to point to the need for more testing. So what I've got to do here is I've got to figure out beforehand, how am I going to deal with that? Okay, when have I achieved the risk levels that I need so that I can feel safe about my system? Okay, where am I going to stop? What I'm talking about here is not cheaping out. I'm not talking about stopping because, you've only got a certain amount of money. Although, money is necessary and you need money to test. What I'm talking about here is when is it the right time to stop? I flew down here on a Boeing 737. I think Boeing's a great company, and I hope they did a lot of testing to make sure that I'd get down here in one piece. But ultimately, they had to put the 737 into production, or, I'd be riding down here on a horse, right? My AMI system is not going to benefit anybody if I never get it deployed. So I've got to look with a really sober eye at, what my testing looks like, when do I stop, what are the other parts of my security program that kind of, pick up where testing leaves off so that I can deploy the right way and not rely, on an infinite, large-scale test plan. So we've got to figure out how to handle transition to production. The project is winding down. But I would say if testing is important during the project phase, why is testing any less important during the production phase? As Bob said, we've got systems which could have 50 or more years of life. Many new versions of applications, many great devices have yet to be added to the AMI system. Part of the advantage of AMI is that I'm open to, adding new devices to the network. That's what I want with an AMI system, but I've got to make sure that I do it safely. What if some defects survive the project? How are you going to manage them to closure? You could say, well, I'm going to do another test cycle to make sure it's closed. Well, maybe a little easier said than done. You may not have that full scope test environment available anymore. You may not have your whole team available anymore. Think about what evidence you would use to close those defects. What evidence would be acceptable to you? What kind of assertions? Maybe a test by somebody else that you trust with, evidence, screenshots, and, assertions from their, management and so forth that, these are actual tests. Maybe you need to review their test environment. All of this is possible, but think about it beforehand and get those agreements in place. Because ultimately, remember, we need to deploy the system safely, and I'm only going to be able to do that if I can close those defects with real evidence. Okay, victory is not achieved by having, X defects that never get closed. Victory is achieved by having 0 defects and X closed, in a really proper and auditable way. Is your third-party test program going to continue? Do you have the resources for that? And I mean not only money, but the people. The market is very tight for these kind of people, right? So are they all going to sit around while you are in the maybe less active production stage? You could move the program in-house. That's a really good idea, especially if you've got a lot of good experience during the project phase. However, that is a different skill set. Make sure that you've got that, resourced up. Make sure that's a business that you want to be in. The test environment has to continue to be production-like. And if it was located off-site, you've got to decide where the test environment is going to live. So again, all the questions that you answered when you were going into the project phase have got to be answered for the transition to production stage. Because what you don't want to do is you don't want to drop the ball. You don't want to put huge resources into a test program and then stop the test program, have the production system keep going, and not be able to pick up and harvest all that value and keep your ratepayer safe. So with that, I thank you very much for your attention, and I welcome your questions. Well, please.
What would be criteria for you to classify how critical does it have to get to security markets? Not before or at least as serious.
Sure. So the question was, how serious would it have to be for us to halt deployment? So first, I'm not going to tie this to any particular of my employers. I can say in the abstract that in order to halt deployment, there would have to be no other way to mitigate, change the use case, and so forth. I can tell you, knowing the AMI space and knowing that the equipment was something, or the equipment would be something that was vetted by myself and my team, from day one before the sourcing, that I cannot imagine a situation where we would halt deployment. In other words, decide to put the flywheel meters back. I can think of situations where we would change the configuration, change the use case, and, otherwise make sure that we're not deploying bad stuff. I mean, the consequences of deploying bad stuff are dire. And I don't only mean because somebody's going to get the ability. You talked about the red button. Most modern AMI deployments have remote disconnect and reconnect. Okay, bad guy can turn off the power if we don't do our job right. So the consequences are dire. We also live, somewhat in a fishbowl environment. I mean, we could have multiple regulators. We've got, certainly an InfoSec community that is keeping a real good eye on us. We really don't want to deploy bad stuff, not only for, moral reasons, but if I deploy bad stuff, someone will know, they'll probably know soon, and my chickens will come home to roost. Please. Sure. Bob, do you want to take this one?
Sure. All right. So as I understand the question, it's to do with traditional SCADA stacks and how fragile they are. Well, I'm gonna add on to the nature of your question, if I may, and say that a lot of times AMI infrastructures are eventually going to tie into smart grid infrastructures, and generation, transmission, distribution, and the customer domains are all going to be connected from end to end. Right? At that point in time, it's really important to understand that what's happening in the AMI space is actually going to tie in to the substation and transmission assets, and we're going to run into protocols that have been in the SCADA networks for 1,000 years now, right? In that case, a lot of times I was mentioning old protocols being used in new ways, right? Or under new circumstances. You're going to find the necessity for hardening and armoring systems, bringing that information over from IT type systems and relying on layers of encryption, relying on hardening of things that hadn't been hardened before, right? And that's just prudent IT activity. I hope that answers your question.
It does. I think, the question of are we doing a better job, or the manufacturers doing a better job of designing their networking stacks to be more robust and have capacity?
So I think last year everyone saw a lot of outing of DNP3. Okay, that was all over the place. A lot of conventions. There was a lot of people that stood up and basically said, yeah, look, there's a problem in DNP3, and this is what it looks like, right? So to that end, you're starting to see a lot of reactivity from manufacturers fixing those problems or addressing them. And that evolution is now kicking up because the marriage of IT and OT coming together. All right. Any other questions?
Okay, thank you very much.